We have breaking news this morning from Earth orbit, where astronauts from a SpaceX capsule are carrying out the first ever commercial spacewalk. Mark Strassman is tracking the Polaris Dawn mission.
SpaceX has just achieved the first commercial spacewalk in history, reaching farther into space than anyone has in the last 52 years. This happened on its Polaris Dawn mission, led by Jared Isaacman and engineer Sarah Gillis.
So it looks like a perfect world.
This event marked Isaacman as the first private individual to exit a spacecraft in orbit. Together, they ventured into the vastness of space, far from the safety of their craft. What implications does this have for the future of space travel as private citizens venture among the stars? Before we get into this, it's clear that SpaceX has done something more amazing than we ever thought possible, and there's even more exciting stuff ahead. The last dawn of commercial space travel. The two of them exited the Crew Dragon capsule, a special spacecraft designed for these daring missions, and floated in space at an incredible altitude of 458 miles above Earth. This is the highest point reached by humans since NASA's Gemini 11 mission in 1966. The main goal of their spacewalk was to test SpaceX's new extravehicular activity, EVA suits, which are created to protect astronauts from the severe conditions of space. As they tested the new suits, they were about to find out something big about what people can do in space. While outside the spacecraft, Isaacman and Gillis performed several tasks to carefully check every part of these new suits, making sure they worked correctly in the challenging environment of space. But that wasn't the end of the story.
Dragon SpaceX event complete.
Their successful test didn't just provide valuable data, they also opened up new possibilities for future commercial space travel. This is an important step forward, showing what private companies like SpaceX can achieve far beyond Earth. The SpaceX Crew Dragon is a game changer in space travel, marking the first time a privately owned spacecraft has taken humans beyond Earth's atmosphere. Right from the start, there is a sense of excitement as we begin to understand the engineering brilliance that has gone into creating the Crew Dragon. This spacecraft was built to solve some of the most challenging problems in space travel. Designing it required years of training, experience, and a lot of creative problem solving. But these challenges were just the beginning. This exploration is brought to life with support from Brilliant Organization, a platform that helps people learn math and science through interactive lessons. Whether you're a professional or a student, you can dive into practical, hands-on lessons that sharpen your skills and deepen your understanding of complex subjects. The Crew Dragon is a human-rated spacecraft, meaning it is specially designed to carry people safely into space. Traditionally, only government agencies with huge budgets could afford space missions. But SpaceX broke that mold, becoming the first private company to take on the massive task of designing and building both rockets and spacecraft on its own. This accomplishment made NASA, the United States Space Agency, one of its biggest customers. The International Space Station, ISS, has been in operation since the early 2000s and has always been occupied by astronauts who travel back and forth. After the retirement of the American Space Shuttle in 2011, the Russian Soyuz spacecraft was the only way to get astronauts to the ISS. That changed in 2020 when the Crew Dragon started launching astronauts from American soil again. This marked a new chapter in space travel. But the new beginning brought its own set of challenges. The Dragon spacecraft has evolved over time. The first version, Dragon 1, was made only for carrying cargo and completed over 20 missions to the ISS. After this came the Dragon 2, which comes in two versions, Cargo Dragon, which transports supplies, and Crew Dragon, designed to carry both people and cargo. The Crew Dragon is made up of two main parts, the capsule and the trunk. The capsule is the section where the astronauts live. It is pressurized, which means it has breathable air and a comfortable temperature for the crew. At the front of the capsule is the nose cone, which protects important sensors and docking equipment. Once in space, this cone opens up to allow the Crew Dragon to dock with the ISS. The capsule has 16 Draco thrusters, small engines that help it move and adjust its path to line up correctly with the ISS. These same engines are also used when it's time to come back to Earth. In an emergency, stronger engines called Super Draco thrusters can push the spacecraft away from danger during launch. But this isn't the most remarkable part yet. Underneath the capsule is a thermal shield. This shield protects the crew from the intense heat generated when the spacecraft re-enters Earth's atmosphere. Initially, SpaceX had planned to add landing legs to the thermal shield so the spacecraft could land on solid ground. However, this idea was abandoned due to the high costs and technical difficulties. So the Crew Dragon continues to make water landings, a safer and more traditional method. The trunk of the Crew Dragon serves as storage and houses the radiator and solar panels that provide power to the spacecraft. Unlike older models where solar panels unfolded in space, the Crew Dragon has panels fixed to its sides. This design makes power generation simpler and more reliable. Inside the capsule, up to 7 astronauts can be seated, but NASA usually uses only 4 seats to leave more room for cargo. The Crew Dragon features modern touchscreen controls, a big change from the button-heavy panels of older spacecraft. Most flight operations are automated, freeing up the crew to focus on their mission tasks rather than manually controlling the spacecraft. As the mission comes to an end, the trunk, which doesn't have a thermal shield, separates from the capsule and burns up upon re-entering Earth's atmosphere. The capsule, however, safely returns the crew, along with any scientific experiments or cargo they have on board. But that's still not the full story. One of the most innovative aspects of the Crew Dragon is its reusability. Unlike older spacecraft that were used only once, the Crew Dragon can be used for multiple missions.
And David, St. Jacques reporting, everything looking good?
This reduces costs and allows for more frequent space travel. This idea of reusability not only shows the technical skill of SpaceX, but also sets a new benchmark in aerospace engineering, making space travel more affordable and opening up new possibilities for the future. Now let's explore how the Crew Dragon's first crewed mission marked a new chapter in space travel, from beloved astronauts to innocent civilians.
Dragon, SpaceX, go for launch.
The first flight of the SpaceX Crew Dragon with astronauts on board took place in May of 2020, marking a historic moment. This flight carried 2 NASA astronauts who safely reached the International Space Station and docked there. Since then, the Crew Dragon has completed more missions, including one named Inspiration 4, which carried 4 civilians, and another mission with a private space company, Axiom Space. More missions are already planned for the future, showing that the space industry is changing in a big way.
2, 1, 0.
The Crew Dragon lifts off on a Falcon 9 rocket, which is another invention by SpaceX. The rocket's name, Falcon 9, was inspired by the Millennium Falcon from Star Wars, giving it a bit of fun and cool factor. These launches happen at the Kennedy Space Center in Florida, specifically at Launch Complex 39A. This location has a long history of important launches and now has a modern look thanks to SpaceX's updates. In the past, NASA moved rockets to the launch pad in a vertical position, a method called rollout. But SpaceX has brought a new approach to this process. Next to the launch pad is a facility where the rocket and Crew Dragon are put together in a horizontal position. Then they are slowly transported to the launch pad using a machine called a transporter erector. After arriving, the whole assembly is lifted to stand upright, a process that takes several hours. This method of moving rockets horizontally isn't new. The Russians have used a similar approach with their Soyuz rockets since the 1960s. So while SpaceX's method is different from what NASA has traditionally done, it is not entirely unique. On the day of the launch, the astronauts put on their SpaceX suits and head to the launch site in a Tesla Model X car. This link between SpaceX and Tesla is no accident, as both companies were started by Elon Musk. This connection shows how Musk's different ventures work together. When they arrive at the launch complex, the astronauts take an elevator to the top of the launch tower. They then cross a walkway called the Crew Access Arm to reach a room at the end known as the White Room, where they get help from technicians to enter the Crew Dragon. This step is called Crew Ingress. Inside the capsule, there are 4 seats for the commander, pilot, and 2 mission specialists. Once they are inside, the seats lean back to a launch position, and the commander and pilot use 3 touchscreens in front of them to control the spacecraft. The crew enters the capsule about 2 hours before the launch. Then, about 45 minutes before launch, the Crew Access Arm is pulled back. 35 minutes before liftoff, the fueling process for the Falcon 9 begins. The rocket has 2 stages. The first stage, powered by 9 Merlin 1D engines, and the second stage, powered by a single Merlin vacuum engine. The name Falcon 9 comes from the 9 engines in the first stage. The Falcon 9 is partly reusable, but not fully yet, as the second stage cannot be recovered after launch. But this is not the most challenging part. The first stage of the rocket is designed to be used again. Soon I'll explain how this reuse works. In this entire rocket setup, only the capsule and the first stage are reused. You can sometimes tell if a first stage is being reused because it might look a bit worn compared to a brand new one. But this isn't the end of the story. This strategy of reusing parts is key to SpaceX's plan to lower the cost of space travel and make launches more frequent. By doing this, they hope to make space more accessible and open up new possibilities for exploration. But even with these advances, the road ahead is still long. SpaceX's approach of reusability is like a breath of fresh air in an industry where rockets were usually used only once and then discarded. When a rocket's first stage lands back on Earth after a mission, it is refurbished and prepped for another flight. This process of using rockets multiple times is one of the big reasons why SpaceX can offer more affordable launches. It's like recycling, but on a much grander scale. However, this hasn't been without its difficulties. Landing a rocket back on Earth safely is incredibly tricky. The first stage needs to withstand extreme heat during re-entry and then navigate to a precise landing spot, often a floating platform in the ocean or back at the launch site. In the early days, several attempts ended in fiery explosions or rockets tipping over. But SpaceX learned from each mistake, fine-tuned its technology, and now regularly lands and reuses its rockets. But that's not all. While reusing the first stage is a big step forward, SpaceX has bigger dreams. They aim to make even the second stage reusable in the future. This would mean that almost the entire rocket could be used again, further cutting down costs and making space travel even more common. Next, let's dive into the details of launching the Crew Dragon into space. The art of spacecraft docking. The launch of a spacecraft is always an exciting moment, marking the shift from months of preparation on the ground to an incredible journey into space. One word you might hear a lot during these launches is nominal. When the flight controllers say that things are nominal, it means everything is going according to plan, giving a sense of relief and accomplishment to everyone involved. About 2 minutes and 40 seconds into the flight, the first stage of the rocket shuts down. This is called MECO, which stands for Main Engine Cutoff. Right after this, the first stage separates and begins its return to Earth. At the same time, the second stage of the rocket ignites and pushes the spacecraft into orbit. This moment is very important because it ensures the spacecraft is on the right path to circle around the Earth. While the second stage continues its journey, the first stage starts getting ready to come back. It uses cold gas thrusters to flip itself around, a move known as the flip maneuver. Then small wings called grid fins open up to help guide its descent back towards the ocean, where a drone ship is waiting at a carefully chosen spot. To slow down as it re-enters the Earth's atmosphere, the rocket uses 3 of its engines in what is called the entry burn. Just before landing, another engine fires up to slow it down even more, and landing legs extend to allow for a smooth landing on the drone ship. But this is only part of the story. This careful series of steps allows the first stage to be recovered and used again for future missions, showing SpaceX's focus on saving money and protecting the environment. Meanwhile, up in space, the second stage completes its job by placing the Dragon spacecraft into the correct orbit. About 8 minutes and 50 seconds into the flight, this stage stops firing, known as SECO, or second engine cutoff. Unlike the first stage, this part of the rocket isn't made to be used again. Eventually, it will fall back to Earth and burn up in the atmosphere. As the Dragon spacecraft settles into orbit, the nose cone opens up to reveal sensors and thrusters that will help it dock with the International Space Station, ISS. At this point, the crew on board begins to feel weightlessness for the first time. The journey to the ISS usually takes about 24 hours. During this time, the Draco thrusters on the spacecraft are fired several times to change its orbit and slowly move closer to the station, ensuring a safe and controlled approach. But this isn't the toughest part yet. There are 2 ways to connect a spacecraft to the ISS: berthing and docking. Berthing means the spacecraft moves close to the station, and then a robotic arm from the ISS grabs it and pulls it in to connect it securely to a docking port. This method was used by the original Dragon spacecraft and requires some manual help to get attached to the station. Docking, on the other hand, is a much more automated process, like what the Crew Dragon uses. The spacecraft lines itself up and connects directly to the station's port without needing the robotic arm. This shows how far spacecraft technology and automation have come. The spacecraft aims for a specific spot at the front of the station called Node 2, or the Harmony module. Attached to this module is the Pressurized Mating Adapter, PMA, which comes in 3 versions on the ISS. PMA-1 is located in the middle of the station, while PMA-2 and PMA-3 are at the front. Back in 2011, PMA-2 was the site where the Space Shuttle made its last docking. Since then, a new device called the International Docking Adapter, an IDA, has been added. This adapter uses a more modern docking system, also used by the Crew Dragon, allowing it to dock at 2 different places on the station. Most missions usually dock at the front, but that is just the start of the process. To begin the docking process, the Crew Dragon extends a soft capture ring. The spacecraft then follows a series of steps, moving to specific points in space, called waypoints, where it pauses to check if everything is working correctly and it's safe to move forward with docking. The first point, waypoint 0, is 400 meters directly below the ISS. After stopping here, the spacecraft moves to waypoint 1, which is 220 meters directly in front of the station. At this spot, the spacecraft aligns itself perfectly with the docking port, always keeping the capsule pointed toward its target. Then it slowly moves to waypoint 2, only 20 meters away from the docking port. To stay on the right path, the spacecraft uses its small engines, called Draco thrusters. But this isn't where the real challenge ends. As the Crew Dragon carefully moves closer, it reaches a crucial moment called the chop or crew hands-off point. At this point, less than 5 meters from the docking port, the crew no longer controls the spacecraft. If anything goes wrong at the last moment, the computers on board will handle it automatically, without needing any help from the crew. When the Crew Dragon first makes contact with the station, its soft capture ring touches the ISS. This moment is called the soft capture phase, but it's just the beginning. This initial connection isn't strong enough to hold the spacecraft securely. After this first touch, the ring slowly pulls the spacecraft closer to the station for what's called a hard capture. During this phase, 12 hooks lock the spacecraft tightly to the station. This whole docking process takes about 2 hours to complete, but even then, there is still more to do. Once the spacecraft is securely docked, the next step is to pressurize the area between the Dragon and the station, which is inside the International Docking Adapter. This step makes sure that the temperature and pressure levels are safe and equal on both sides. After this, the first hatch, called the APAS hatch, and then the Dragon hatch, can be opened. Finally, the new astronauts can join those already on the station. This entire docking process includes many carefully planned steps, all designed to ensure everything goes smoothly and safely. The use of advanced docking adapters and automatic systems shows how much technology has improved in space travel today. These improvements not only make sure the crew is safe, but also make each mission more efficient, allowing the astronauts to quickly switch from space travel to living and working on the station. But that's not the end of what makes this process special. Each time a spacecraft docks with the ISS, it plays a part in the ongoing research and international teamwork that the ISS represents. Every new mission helps us learn more about living and working in space and brings countries together to work on common goals. The importance of each docking goes beyond just connecting a spacecraft to a station. It involves careful planning, advanced technology, and teamwork from people all over the world. The ISS is not just a place for experiments, it's a symbol of what can be achieved when people from different backgrounds and countries come together to explore the unknown. As more spacecraft make their way to the ISS, we continue to push the boundaries of what we know about space, creating a future where exploration and discovery are possible for everyone. Each step forward brings new lessons and new possibilities, showing that even the most complicated processes can be mastered with patience, practice, and collaboration. The story of docking at the ISS is just one chapter in the larger story of human exploration, but it is an important one that reminds us of our shared mission to reach for the stars.
Humanity's whisper across the cosmos. Bill Nye, a well-known science educator, views the Voyager missions as a testament to human curiosity and ingenuity, pushing the boundaries of our solar system and venturing into the unknown reaches of space. This durable spacecraft has continuously relayed data, charting remote planets and venturing into the realm between the stars. What could this message signify? The implications of this communication could reshape humanity's understanding of the cosmos. Launched by NASA in 1977, the twin Voyager spacecraft were the first to send representations of humanity into the void, each equipped with a golden record, a disk containing sounds and images portraying life on Earth. Voyager 1, in particular, has traveled well beyond the confines of the solar system, suggesting that the universe might be responding to humanity's call. Bill Nye speculates that humanity might be on the verge of a discovery that could redefine its historical perspective. The vastness of space has long fueled speculation about the existence of other life forms, possibly within the Milky Way, or even in distant galaxies. With countless galaxies, each hosting billions of stars, many orbited by Earth-like planets, the probability of encountering numerous other civilizations seems plausible. But this wasn't the most exciting part. The late Carl Sagan, an influential astronomer, once estimated that the galaxy alone might host up to 1 million civilizations. This prospect has excited astronomers and researchers for decades, particularly during the optimistic era of the 1960s. Organizations like SETI, or the Search for Extraterrestrial Intelligence, have dedicated themselves to the monumental task of finding these extraterrestrial societies. SETI's efforts focus on two primary methods of communication: direct encounters and long-distance signals. While face-to-face contact seems impractical due to the vast distances involved, sending and receiving radio signals across space is more feasible. In 1974, astronomers broadcast a 210-byte message from the Arecibo Observatory in Puerto Rico toward the star cluster M13. This message contained fundamental information about humanity and its place in the cosmos, including the structure of DNA and details about crucial elements. Even with these efforts, direct communication with potential alien civilizations has been limited. Most of the time, astronomers rely on silently monitoring for any extraterrestrial signals. Radio telescopes are invaluable in this pursuit, capable of detecting longer energy waves invisible to optical telescopes. These devices focus on stars similar to the Sun, tuning into the quieter microwave spectrum between 1,000 to 3,000 megahertz to discern faint signals against the backdrop of cosmic noise. A noteworthy frequency, 1,420 megahertz, linked to hydrogen, serves as a universal beacon that any knowledgeable civilization might use to make contact. Since the 1960s, international teams have tirelessly scanned the heavens for signals emanating from the galaxy and beyond. As humanity continues to explore exoplanets, Voyager 1's role becomes increasingly significant, beyond what was imagined nearly half a century ago. This spacecraft, despite its age, remains robust, continuing to transmit data and hinting at an uncertain yet potentially enlightening future filled with discoveries. The Voyager missions capitalized on a rare alignment of the outer planets, an event occurring once every 176 years, which allowed the spacecraft to efficiently slingshot from one planet to another, conserving fuel and extending its journey across the solar system. This strategic use of planetary gravity dramatically enhanced the mission's scope and longevity, enabling these probes to reach into the interstellar medium where they continue to explore and inform. NASA originally planned for its spacecraft to travel far beyond the outer planets like Pluto, Saturn, and Jupiter, with some even intended to zoom past Uranus and Neptune. Unfortunately, budget constraints forced NASA to scale back these grand plans. Despite these cuts, the two launched Voyager spacecraft achieved remarkable feats. Voyager 2 had the opportunity to pass by Jupiter, Saturn, Uranus, and Neptune, while Voyager 1 focused on the first two planets. There is more exciting information to come on this topic. Recognizing that these spacecraft would eventually leave the solar system, NASA decided to include two golden records on the Voyagers. These records hold a variety of sounds from Earth, including whale songs and music by Chuck Berry, and messages in 55 different languages, hoping to spark the curiosity of any extraterrestrial beings who might discover them. These 12-inch gold-plated copper discs also feature diagrams on how to play them, and details pinpointing the sun's location relative to specific pulsars. These pulsars are a type of neutron star that could help locate the solar system. The spacecraft are equipped with 3 radioisotope thermoelectric generators, which convert the heat from radioactive plutonium decay into electrical power. Each Voyager carries 10 scientific instruments, including a magnetometer to measure magnetic fields, a dual-camera imaging system, various spectrometers for material analysis, and sensors to detect charged particles and cosmic rays. Through these tools, the Voyagers have conducted a total of 11 scientific investigations, sending back invaluable data that helps scientists understand more about the distant planets and moons they visit. But this wasn't the worst part. Voyager 1's launch on September 5, 1977, nearly ended in failure when the rocket almost ran out of fuel. However, the launch ultimately succeeded, and Voyager 1 quickly surpassed its twin, Voyager 2, leaving the asteroid belt between Jupiter and Mars behind. By April 1978, Voyager 1 was sending back its first images of Jupiter. In March 1979, it surprised NASA by revealing a thin ring around the giant planet and discovering 2 new moons, greatly enhancing knowledge of the outer solar system. Voyager 1's journey to Jupiter and beyond involved more than just visiting distant planets. It was about uncovering new worlds within the solar system. For example, Voyager 1 captured detailed images of Jupiter's large moons, Io, Europa, Ganymede, and Callisto, as well as the smaller moon, Amalthea. Similar to the earlier Pioneer spacecraft, Voyager 2 showed that these moons were dynamic worlds in their own right, each with distinctive features. Voyager 1 revealed that Io is covered in colorful yellow, brown, and orange spots, and is dotted with many active volcanoes, indicating that moons can have dynamic interiors similar to planets. Additionally, Voyager 1's images of Europa showed a smooth surface crisscrossed by lines, suggesting it might be covered in ice with a possible ocean beneath. Subsequent research supported the notion that Europa might host a vast subterranean ocean of liquid water, potentially harboring life forms akin to those on Earth. On March 5, 1979, Voyager 1 made an incredibly close approach to Jupiter, flying within 174,000 miles of the giant planet's stormy cloud tops. Saturn was its next destination. A year later, the spacecraft reached Saturn and began sending back detailed pictures of the ringed planet, revealing as many surprises as Jupiter had. One of Voyager 1's specific objectives was to study Saturn's F ring, a delicate and newly discovered ring. Using its advanced cameras, Voyager 1 discovered 2 new moons, Prometheus and Pandora, which helped maintain the particles in the F ring in an orderly arrangement. It also identified a new ring, the G ring, and provided detailed images of several of Saturn's moons. After these encounters at Saturn, the main part of Voyager 1's mission concluded, and the focus shifted to tracking the spacecraft as it continued its journey toward the outer limits of space. On February 14, 1990, 20 years before it would venture into the uncharted territories of interstellar space, Voyager 1 turned around to take a photo of Earth from an astounding distance of 3.7 billion miles away. This iconic image, showing Earth as a tiny speck bathed in a beam of sunlight, famously known as the pale blue dot, remains one of the most memorable pictures in space exploration history. As Voyager 1 travels further, we find more unexpected things in space. Voyager 1's interstellar adventure. On that special day, a series of photos were taken, capturing not only the Sun, but also 5 other planets and a stunning view of the solar system. One image, known as the pale blue dot, stands out, showing just how small Earth's presence is in the vast universe. The journey of Voyager 1 added to this perspective when, in August 2012, it crossed the boundary of the heliosphere. This boundary, created by the Sun, is a bubble filled with charged particles and magnetic fields. Voyager 1's entry into interstellar space was confirmed thanks to a significant solar eruption in 2013, which shook the space around the spacecraft and made nearby electrons move. This helped scientists figure out that Voyager 1 was in an area where the electron density was surprisingly higher than inside the heliosphere, which was unexpected. Normally, at the edge of the heliosphere, electron density drops. Looking back at Voyager 1's past records confirmed that it left the solar system on August 25, 2012. This was figured out by studying electron movements and solar particle measurements, which are tiny bits emitted by the sun. Coincidentally, this date was also the day Neil Armstrong, the famous astronaut, passed away. On this important day, Voyager 1 recorded a 9% increase in cosmic rays and a 10-fold decrease in solar particles, while it was about 11.25 billion miles from the sun. Since its launch, Voyager 1 has continued sending valuable data, showing high levels of cosmic radiation and interactions between stellar and solar particles. The spacecraft's durability continues to impress NASA engineers. In 2017, they successfully reactivated its backup thrusters, which hadn't been used since the Saturn flyby in 1980, to realign it for better communication with Earth. This switch was necessary because the primary thrusters were wearing out. After capturing the famous pale blue dot image, NASA had to turn off the cameras and other instruments due to the difficulty of capturing light in deep space. By the next year, Voyager 1 stopped sending data, entering a silent phase. The vast distance of 15 billion miles means commands from Earth take nearly a full day to reach Voyager 1, and it takes an equal time for a response, making interaction with the spacecraft challenging. Voyager 1 started malfunctioning. For months, NASA worked on a remote fix, similar to diagnosing a cavity with a puff of air. They sent a command to check its memory, revealing a glitch in the flight data subsystem, which handles all data collection and processing. Instead of useful data, this system kept outputting binary gibberish. NASA couldn't replace the faulty chip from so far away and had to find a creative way to manage the corrupted code. They split the problematic code, spreading the pieces to different memory sectors to ensure functionality. This operation led to a historic software update from an unprecedented distance in space exploration. This successful update has left NASA and space fans excited for new discoveries from Voyager 1, which continues to be a key source of cosmic information. This achievement not only shows NASA's team's ingenuity and perseverance, but also sets a precedent for future remote problem-solving in space missions. As they await new data, the questions and excitement about the universe continue, driving ongoing interest and speculation about what lies beyond in the vast expanse of space. But even this was not the end of the challenges. As time passed, Voyager 1 faced increasing difficulties due to the extreme environment of deep space. The power levels of the spacecraft, which relies on a nuclear power source, began to drop, forcing NASA to make tough decisions about which instruments to keep running. In the face of these challenges, NASA's engineers worked tirelessly to manage Voyager 1's power supply, prioritizing the most critical instruments for continued data collection. They devised strategies to conserve energy, such as turning off non-essential systems and rotating between instruments to gather as much information as possible while preserving the spacecraft's longevity. Yet, another unexpected twist awaited. A cosmic ray storm hit Voyager 1, causing temporary disruptions in its communication with Earth. The team had to patiently wait for the storm to pass, anxiously monitoring the spacecraft's status. Thankfully, Voyager 1 weathered the storm and resumed normal operations, a testament to its robust design and the careful planning of its mission team. Despite these hurdles, the data Voyager 1 continues to send back offers invaluable insights into the nature of interstellar space. Each piece of information adds to the understanding, helping scientists refine their models of the universe. The spacecraft's journey reminds everyone of Earth's tiny place in the cosmos, but also of the vast potential for discovery and exploration that lies ahead. Each mysterious signal from space brings us closer to amazing discoveries. Deciphering the WOW signal. On August 18, 1977, Something unusual caught Jerry Isaacman's eye while he was looking over some space data. Instead of the usual numbers, he saw a string of letters and numbers showing a radio transmission 30 times louder than the normal background noise of space. Excited, Isaacman grabbed a red marker and wrote "Wow" next to the sequence 6EQUJ5. This event, known as the WOW signal, is one of the strongest clues that humanity might have received a message from extraterrestrials. Although the signal only lasted 72 seconds, its unique features made many astronomers, both amateur and professional, think it could have come from an alien spacecraft. Many scientists believe this signal could be from another civilization. For one, the WOW signal was recorded at a frequency of 1,420.4556 megahertz, which is almost exactly the electromagnetic wavelength of hydrogen. The SETI team thinks this frequency is perfect for interstellar communication. Another interesting thing about the WOW signal is its shape. The Big Ear telescope first recorded the signal's intensity at 6, then it increased to an E, and finally to U, representing the number 30, before decreasing back to 5. This pattern forms a nearly symmetrical pyramid on a graph, making the signal stand out. The narrow focus of the WOW signal is also intriguing. Unlike the wide range of radio waves emitted by stars and galaxies, the WOW signal was extremely narrow, which suggests it might come from an artificial source, possibly from intelligent beings on another planet. The Big Ear telescope picked up this signal while looking at an area near the constellation Sagittarius, a star-packed region toward the center of our galaxy. This area could be a good target for a technologically advanced civilization trying to contact others. Despite many attempts, no one has ever detected the WOW signal again, leading to debates about its origin. Some think it might have been a radio signal from Earth, reflecting off space debris, an unintentional transmission from a secret military satellite, or just a glitch in the Big Ear's computer. Another puzzling issue is the signal's brief duration. If it came from an alien civilization, why was it so short-lived and never repeated? Also, the power needed to send such a strong signal across vast distances suggests an incredibly advanced source, possibly beyond even a Type 2 civilization on the Kardashev scale, which measures technological advancement based on energy use. The unresolved nature of the WOW signal keeps it a hot topic in the search for extraterrestrial life. Adding to the cosmic mystery is an object named GPMJ 183910, which sends radio waves to Earth every 22 minutes for over 3 decades. Thought to be a dying star emitting energy from its poles, it spins slower than expected for such activity. Astronomers usually see faster changing patterns, making this one particularly puzzling. Over time, some stars cool and collapse into neutron stars, which are extremely dense objects. NASA says these stars can pack billions of tons of material into an area as small as a city. From their magnetic poles, neutron stars emit beams of energy and light, similar to a lighthouse's beacon. These signals are visible only when the beams sweep past Earth. The discovery of the WOW signal led to further findings about such mysterious signals and objects in the cosmos. The early researchers who first detected these strange signals thought they might be messages from aliens because of the signal's regular timing. They later realized they were observing emissions from stars nearing the end of their lives. These signals come from pulsating neutron stars that gradually slow down until they reach a death line. When a star crosses this line, it begins to break apart, shown by its pulses becoming infrequent and irregular. A particularly odd case involved GPMJ 183910, which emitted pulses every 22 minutes, each lasting about 5 minutes, much slower than any observed before. Some scientists speculated these might come from a magnetar, a neutron star with intense magnetic fields. Further investigation revealed the true nature of GPMJ 183910. It had been sending signals with remarkable regularity, unnoticed by global observatories for years. This star's prolonged activity challenges the understanding of how stars evolve and die. Amid these cosmic mysteries, Voyager 1 and Voyager 2 continue their journey through the galaxy, even though they no longer send signals back to Earth. They carry the Golden Records, which are collections of Earth sounds, music, and images meant to represent humanity to any potential intelligent finders. These records also show Earth's location, sparking debates over whether it's safe to reveal our position so clearly. In L. Ron Hubbard's science fiction story, Battlefield Earth, this kind of openness leads to an alien invasion. The story describes Earth as a small system on the edge of the galaxy, discovered by alien invaders because of Voyager's data. This cautionary tale reflects real concerns about the dangers of broadcasting Earth's location into space. As Voyager's probes drift farther away, carrying detailed maps of Earth's location, they represent humanity's quest for knowledge and connection. But they also raise important questions about the risks of reaching out into the vast unknown. The ongoing debate highlights the complexity of contacting extraterrestrial life, balancing the excitement of discovery with the need to protect humanity in a huge and largely unexplored universe. What do you think? Could broadcasting our location into space lead to catastrophic events like those in Battlefield Earth? Leave your comments, and subscribe for more thought-provoking content.